Cameron Crandall is a senior technology manager at Kingston, and he helps to lead the engineering efforts and the new and current products, and he also serves as the technical advisor for Kingston's sales, marketing, and public relations. Lately, he's been instrumental in overseeing the launch of Kingston's new lineup of enterprise-grade solid-state drives. Cameron, thank you so much for being here with us this week.
Thank you. Happy to be here.
Cameron, I've got some great questions for you. We want to go right into it. First of all, businesses demand fast performance from their storage, whether it's an in-house server hosting network shares, or perhaps it's an internet-facing web server. IT admins like myself, we've got a need for speed, my man, probably because realistically when things get slow, it's us who have to hear the complaints. So being a technology leader yourself, Kingston must receive a lot of requests for more speed or higher capacity from your customers. So my question is, from your perspective, what are customers looking for? And I guess how is that influencing Kingston's innovation as well?
So yeah, great questions. So yeah, both capacity and performance are drivers in the industry today. Specifically in the data center, what we're being asked for is definitely higher capacities, but also performance consistency from the SSD in the data center. There's very much now a distinction in performance between what a client SSD delivers and an enterprise SSD delivers. And over the last, I'd say 3 to 4 years, this concept of performance consistency and what they call QoS, or quality of service, has really become key to the buying decisions by IT administrators and storage architects. So they're not necessarily looking for peak levels of performance they might find on a data sheet, but give me that performance consistently over my workload.
Yeah. Now, when I hear QoS, quality of service, I think about my internet connectivity. Yep. We're doing this interview over Skype, so we're using QoS technology in order to delegate packets so that our feed is really good during the interview. So how does QoS play into solid-state storage?
So it's funny you mentioned that. The term QoS actually came from Ethernet and networking bandwidth. It was the guaranteed quality of service or performance you would get from your internet provider. So that term has been adopted by the SSD industry, but it relates to the consistent delivery of I/O performance from the SSD and latency performance. So what a data center customer wants in their storage device today for server workloads is consistent levels of I/O delivery from the SSD, as well as consistent latency. We can't have big latency spikes in our application, and we can't have I/O cliffs occur that show up in the end application somewhere, because that's a poor experience on a website. That is a e-commerce site that is slow, where you potentially have a buyer that moves away from the site and goes and purchases somewhere else. So
sure.
Data centers today are really looking at and designing their own test to test SSDs for this performance consistency. We cannot deliver a client SSD to a data center customer like we could, 5-6 years ago. Today, they're demanding this level of performance consistency in the storage devices that they're buying.
Yeah, and I think that's probably being pushed by, we're using virtualization more than ever. We're using network-attached storage and iSCSI devices more than ever. So this is shared resources against many different servers, many different web services, databases, and things like that. So that consistent speed is really important to us in the data center and in business. Cameron, can you tell us what's got you personally really excited about the new Kingston data center DC500 SSDs, and also kind of how they differ from previous generations of the drives?
Sure. So we're probably best known for client and consumer SSDs in the marketplace. I mean, if you were at an industry event and you asked somebody what they thought of Kingston SSDs, they'd probably say, hey, they're a great client or consumer brand that I might find in a retail outlet.
Gaming, my friend.
And gaming,
Yeah.
yeah, for sure. But we have been selling enterprise class SSDs for the last probably 5 or 6 years, but our product portfolio has been quite small. We've had kind of 1 or 2 drives in that segment, and we've got a great customer base from our DRAM relationships. And we've been able to sell our enterprise SSDs into those customer bases. Now moving forward with this new DC500 line that we've just launched, we've added 2 drives to the line, and we have 3 more drives coming out before Q3. So we're really expanding the line, and really going after different tiers of enterprise business. We're heavily focused still on SATA today, even though NVMe is kind of the big buzzword. We're finding that in the typical channel that we sell to, there's still a lot of serial ATA being used in data center servers. A lot of the tier 2 and tier 3 cloud companies are still heavily based on SATA. So the DC500 is a SATA SSD offered in 2 different endurance levels, and then we're going to be coming out with another SATA product in that lineup, and then we'll move to 2 NVMe products to help those same customers that are heavily on SATA today transition to NVMe.
Wow. Okay, I want to circle back to that. But first of all, you mentioned that you've got 2 different models that are going to be coming out. So we've got the R and the M. So we're going to see DC500R. We're going to see DC500M. So for me as a C-suite executive who's looking to purchase, well, if one is less money than the other, like what's the difference? Like, why am I looking at an M versus an R, for example?
So the R stands for read-centric workloads, and M stands for mixed use, and those are closely tied to the endurance level of an SSD. So typically a data center customer that's looking to source SSDs for their servers and storage arrays, they're looking at performance and they're looking at endurance. And most data center customers that are making that purchase probably already have an idea of the endurance level that they're looking for in their SSD. So they're looking at either like a sub 1 drive write per day SSD, or they're looking for more endurance at either a drive write or maybe a little bit over 1 drive write per day. So we offer 2 different categories, and just like you said, there is a price difference between those, the R and the M. R being more read centric. So if you had an application that was more 90 to 95% read,
right?
From a cost standpoint, you would be better off buying a DC500R. If you had more of a workload that had a balance of mixed reads and writes, you're going to be writing to that drive more. So you'd want to outfit the server with the DC500M.
Okay.
So it's really workload specific. And that we know from industry analysts that the majority, about 82% of the SSDs that are deployed into servers today require 1 or less than 1 drive write per day of endurance. So we're going after that bigger kind of bucket of business and opportunity. We're not going to be producing 5 and 10 drive write per day SSDs. That's a very competitive segment and a much smaller segment of the market.
Okay, so with 1 drive write a day, immediately the thought that comes to mind is, what kind of capacity are we looking at with the DC500s?
So both models, the R and the M, they're offered in 480, 960, 1.92 terabytes, and 3.84 terabytes.
Wow. So those are quite large capacity. Am I right in thinking, based on your description here, what's coming to mind with the 2 different models, the R and the M, is that the R is going to be more for, like, say, it would be a perfect solution for, say, a web host who's we're uploading files to it once in a while, but realistically, it's all read data. It's people visiting the website. Versus the M would be more for, say, an internal storage for my business network, where we're opening a lot of files and saving those files back to the network drive. Is that accurate?
That's very accurate.
Okay.
In fact, our main customer base that we're going after with these drives is the tier 2 and tier 3 cloud companies, the hosting companies.
Okay. Yeah.
They're still heavily SATA today. They're looking for the kind of the sweet spot in capacity is 960 and 1.92 terabyte. We've got some demand for 4 terabyte, but most of the volume that we're seeing is in that 1 and 2 terabyte capacity range.
Sure. And when you've got lots of drives in an array, it's going to give you much higher capacity once you've got 8 or 12 drives in there.
Correct.
Which really makes me think now, I'm sure like in our standard PC, we're used to having maybe 1 or 2 SSDs in there, and so the difference in power consumption is going to be negligible between, say, an SSD and an old style spinning drive. But in a data center, as I say, we've got each server in the rack is going to have 8 or more SSDs in it, or spinning hard drives. Does switching those servers, so our existing infrastructure, so taking those servers that have 8, 12, 24 drives in them, if we switch those to SSDs, are we going to reduce our electrical usage by any notable amount?
Yeah, absolutely. So we were doing these tests several years ago when SSDs first came out, and we started putting SSDs into servers, and it was kind of a twofold effect. You were getting the benefit of lower power consumption, but the performance you were getting out of the SSD array was many times over, almost 200%.
Wow.
What you were getting from the hard drive arrays. A typical 10 or 15K RPM hard drive consumes quite a bit of power, right?
Sure.
So and like you said, scaled up in arrays of 8, 16, and 24, you can reduce your power footprint by quite a bit by just going to SSDs. And in fact, you might even be able to reduce the number of physical devices, even with an SSD, and get more performance than you were getting with hard drives.
Right.
A lot of the storage arrays and servers that are built with hard drives today are scaled out with hard drives to get performance. That capacity may not be being used, but that they're scaling hard drives to get the performance out of them. So if you don't have to scale hard drives, you're getting the benefit of reduced power consumption and greater performance with fewer drives. So it's the concept of doing more with less.
Yeah, and I expect that with spinning drives, we have to have them spinning 24/7 because you can't wait for the drive to spin up. It's going to take between 4 and maybe 10 seconds to spin up, and nobody's going to wait for a website for that amount of time. So SSDs like zippity zap, just right there, always on. Now, we've got to take a really quick break. We're speaking with Cameron Crandall from Kingston Technology about their new data center drives and the state of solid-state drives in enterprise servers. When we get back, we're going to be learning about how Kingston is addressing the shortcomings of the aging SATA interface and how their new drives deal with latency as well as garbage collection. Stick around. For a limited time, get your hands on limited edition shirts from the Category 5 TV network. These high-quality shirts are manufactured by Teespring, a fundraising website, and your purchase will help support the shows we produce. Get yours today and send us your pictures to be featured on the corresponding show. Visit cat5.tv/shirts to support us and get your official network shirt today. cat5.tv/shirts. This week, we're speaking with Cameron Crandall. He's a senior technology manager with Kingston Technology's SSD product engineering department. And not only does he help to lead the engineering efforts for new and current product offerings, but he also serves as a technical advisor. Lately, he's also been working on bringing you their brand new enterprise SSDs. Before the break, we learned about the new data center DC500 drives. But if I'm going to invest in new storage drives for my company, I need to know how future-ready my investment is and how the upgrade will impact performance for my business in the years to come. We need to have fault tolerance. That goes without saying. So if a drive fails, we can seamlessly replace it and then have the array rebuild the data. But I've heard, Cameron, that In the past, trim has been a problem for SSDs, so we'll call it garbage collection. It doesn't necessarily work well when you put solid-state drives into a RAID array. This, of course, leads to high latency over time, which is not going to be good for the data center or the in-house server performance. But yet, the advancement of technology is still driving us to replace the old spinning drives in our server with solid-state drives. So my question for you, Cameron, is how is Kingston addressing the issue of garbage collection, and is it something that we still need to be concerned with in 2019?
Yeah, absolutely. So garbage collection is a necessity on any SSD. So you have two processes. You've got garbage collection, which is initiated by the onboard SSD controller on the SSD itself, and then trim is actually initiated by the file system, because the file system knows where the invalid data blocks are, so it can send a command to the SSD to do that house cleaning. So the two work kind of side by side. Just know that trim is file system initiated, which has to be passed through a driver and onto the SSD. And then garbage collection is an internal routine that's done on the SSD to keep the drive clean and the blocks clean, ready for new writes to come in. But both processes are trying to accomplish the same thing, which is basically keep the drive in a clean state so that when new writes come into the drive, it can process those writes quickly and you don't have latency and I/O cliffs. And a lot of that firmware tuning that I talked about earlier on with tuning for QoS goes into how we handle a trim command that comes in from the host and how we initiate garbage collection to maintain steady state performance over the drive. So there's firmware techniques that are used. There are over provisioning techniques that are done on the SSD, where we set larger portions of the flash aside to do these background operations efficiently. So there again, I can't stress enough today in today's SSD world how different a client SSD is from a server SSD, and tuning for QoS as being really the key priority. At Kingston for data center SSDs, we put a lot of time into making sure that we're delivering performance consistently. Going to your question about trim and being able to pass a trim command through a RAID controller,
right?
A lot of that has been solved. A lot of the RAID controllers and the file systems now are compatible, and that trim command can come through to the SSD that sits behind a RAID controller. In the early days, that was not possible, but a lot of that has been solved today.
Fantastic. Now, is that like a Linux kernel thing? Is that something that we have to, like, is this hardware related as far as the backplane goes, or is this, where does that come from?
It is in the kernel.
Okay. So software updates.
Software. Yep.
Perfect.
Yep.
That's perfect. And I want to circle back now. Before the break, we were talking a little bit about SATA and how serial ATA is still being used in the data center and in business. And as I think about I/O performance and the overall speed of our servers, we're kind of approaching this point, or maybe we're already there, Cameron, where storage technology is actually finding a bottleneck introduced by the controller itself. Now, your new drives, the DC500s, they're extremely fast, but they're still limited to the SATA speeds, since the typical server backplane is still using that bus interface. So for those of us whose need for speed is borderline on obsession, what is on the horizon as far as something faster goes? You talked about NVMe, and I think NVMe in the server, what could be on the horizon for us here, Cameron?
Yeah, so a great question. So we've been building SSDs with hard drive interfaces for the last 12 years, and there are many, many debates in our industry about this subject, and obviously NVMe was developed to address this problem. The issue is that the number of SATA and SAS sockets that exist in the world today are literally in the billions. So it makes sense for SSD companies like Kingston to develop SSDs with interfaces that have literally billions of opportunities for socket placement. But definitely, so NVMe was developed as a better interface for flash-based SSDs. The tier one data centers that are out there, and these are all the household names that we all know of here, they moved to NVMe, pretty quick. Actually, a couple of years ago.
Okay.
So they're heavy NVMe today. In the channel, though, there's still we're still seeing SATA used heavily, primarily because SATA, even though the SATA interface is a performance bottleneck, it still delivers very, very good performance.
Sure.
And I would say what we've done with SATA over the last several years is we keep improving the SSD technology, and really, like I was talking about around QoS and even peak levels of bandwidth performance, we've been able to really refine the performance capability of SATA SSDs. So they've been able to go out on this long runway and still be very viable solutions at a lower price point than NVMe today. NVMe still carries a price premium over SATA. They are coming together, but until NVMe and SATA are at price parity, I think you're still going to see customers that don't have that huge performance requirement. They're going to stick to serial ATA until they're at price parity, or the system manufacturer forces them to go to NVMe.
Sure, yeah. That's awesome. I mean, I can't wait to see what's next. So just as kind of a final thought here, Cameron, so let's just put a scenario out there. I'm a business exec or an IT administrator. I've already got storage servers in my rack, and I just want to increase the performance, increase the throughput by changing the drives. Is it advantageous for me to pull those old spinning drives and switch over to DC500s?
Oh, absolutely. I mean, there's an immediate, just like we saw on the client side, it is, we all saw kind of a night and day difference on our personal computers.
Like our desktop computers, laptops, switching to SSDs, it's like night and day. Absolutely.
It is. So if you were to, put 4, 8, 16, 24 DC500s behind your existing RAID controller that you're using with spinning disk, you're going to see giant benefits in everything. I/O performance, IOPS go shooting way up. Bandwidth performance is going to shoot way up. Your latencies are going to go way down. So absolutely, that upgrade model still very much is a benefit today.
Very good. Cameron Crandall is joining us from Kingston Technology. Cameron, thank you so much for joining us today, and congratulations on the release of the DC500 as well. We're very, very excited about this new drive.
You're welcome. Thank you very much.
All the best.